Today's lesson is applications involving right triangles and solving the triangle. My learning objective is I can solve real-life problems involving right triangles by applying SOHCAHTOA, the Pythagorean Theorem, the triangle sum theorem, and the right triangle corollary. Let's just take a minute, and where are we on the learning spectrum? Okay, so basic triangle information. Sides are across from angles. We always call the right angle side C with the Pythagorean theorem. So the side across from it is the hypotenuse, and we call that side C. A and B don't matter. They're the two acute angles, but across from A is side A, and across from angle B is side B. From geometry, we also know that when I add all three angles of a triangle, they always total 180. Since we're talking about right triangles, I know that if I add my two acute angles, they total 180. When I am solving for sides, I use the Pythagorean theorem with a right triangle. And I know my leg squared plus my leg squared equals the hypotenuse squared. I want you to think of the formulas more in this format so that it's just a one-step format where I'm solving for A, B, or C directly. So Pythagorean theorem, I am solving for sides. Triangle sum theorem, it's an angle. And then SOHCAHTOA, trig, is sides or angles. Okay, so sine is the opposite leg over the hypotenuse. Cosine is the adjacent leg over the hypotenuse. And tangent is the opposite leg divided by the adjacent leg. Okay, and just a reminder when you're using your calculator, the default mode is degrees, or we want to use degrees, and the default mode is radians. So to switch back and forth, you're going to hit mode, and to be in degrees, the degrees has to be highlighted. To go back to home, you hit second mode, and it brings you back to the home screen. Okay, so let's do a couple examples. From geometry, we learned that I want to identify or label the reference angle first. This is one of the acute angles and is never the right angle. The sides are labeled in terms of the reference angle as the opposite leg, the adjacent leg, or the hypotenuse. So the hypotenuse is across from the right angle. The opposite is the leg across from the reference angle, and the adjacent is the leg next to the reference angle. For this lesson, we are going to round sides and angles to the nearest tenth. So that's 1 decimal place. So that is 1 decimal place. We are going to put the answers on our triangle and in the location of the triangle and circle them. This is kind of just standard how people show work solving the triangle. And we draw lines between all our work just to keep it somewhat organized. Okay, so when we are solving the triangle with those words, I am expecting 3 answers. I am giving you 3 pieces of information, and you are solving for the other 3 pieces. So in this triangle, I am giving you 2 angles and 1 side. So I know this angle is 90 degrees. Oops. So I'm going to solve for angle B, and side C. So since I have the angle 56 given, I'm going to use this as my reference angle. I could use angle B as my reference angle. but I can never use the right angle as the reference angle. So I'm going to identify this as my reference angle. So this is my opposite, this is my adjacent, and this is my hypotenuse. It does not matter. I can solve this in any order. So if you need a starting point, I usually suggest a student start with whatever you have two of. So in this case, I have two angles. So I'm going to solve for the third angle. So I know that angle B and angle A total 90. So I know angle B is 90 minus 56. So angle B is 34 degrees. So it's asking me to round to tenths, and I'm circling. Okay, next I am going to solve for side B. It does not matter. I could solve for side C. It doesn't matter. So I'm going to use trig because I cannot use the Pythagorean theorem because I only have one of the three sides. So I'm going to use trig. And I'm going to use the information I have. I'm going to use the 56 degrees and I'm going to use the 14. So when I am using the reference angle and I'm using 14 and side B, that would tell me I'm going to use tangent because I'm using opposite and adjacent. So I'm going to say the tangent of 56 degrees is opposite 14 divided by side B. So B and tangent of 56 are logically equivalent. So I'm going to switch them. So I'm going to say B equals 14 divided by the tangent of 56 degrees. When I put this in my calculator, I make sure I'm in degree mode. This is approximately 9.4. Oops, I wrote 9.7, 9.4. So 9.4 feet. Okay, so last I'm going to solve for side C. So I can use, again, the original information. That would be my preference. So I'm going to use the 56, the 14, and C. So to do that, the equation that relates all three of those is, again, a trig equation. So that's going to be sine, opposite, over hypotenuse. So sine of 56 degrees equals opposite, 14 over the hypotenuse C. So again, C and the sine of 56 are in a logically equivalent place. So they're going to switch. So C is 14 divided by the sine of 56 degrees, which is approximately 16.9. Or if I wanted to use, I could use the Pythagorean theorem. So I already at this point knew two of my three sides. So I could solve for my third side, which was going to be the square root of 9.4 squared plus 14 squared, taking the square root, and I would get C as approximately 16.9, which that's what I got with my trig. My preference is to use original information, because in this one, I'm using rounded information. Being an engineer, I always want to use original information and round once at the end. All right, let's try example number 2. Solve the triangle. Side A is 16 inches and side B is 12 inches. So I'm just going to draw ABC. So here is A, B, C. Side A is 16 inches. Side B is 12 inches. And I know the 90-degree angle. So I can do anything first. It doesn't matter. So this time I have two sides first, so I'm going to solve for side C. So this is going to be 12 squared plus 16 squared, which is 20. And we usually draw lines in between to just separate our information. It does not matter. I can either solve for angle A or angle B. It does not matter. I'm choosing angle A as my reference angle. It does not matter if I choose B. I'm just picking which one is first in the alphabet. It's okay with me. So if I pick angle A as my reference angle, I want to use my two original pieces information. So this would be my opposite side, and this would be my adjacent side. So that would tell me I'm using tangent. So tangent of angle A is 16 divided by 12. So the measure of angle A is the tangent inverse of 16 divided by 12. So I'm trying to undo the tangent, so that's called tangent inverse. So when I write it as a -1, I say inverse for that -1 and has nothing to do with a power. So again, I need to make sure I'm in degree mode. So this is the measure of angle A is approximately 53.1 degrees. So my last step is I'm going to solve for angle B, and I know angle A and angle B are complementary. So they total 90. So angle B, the measure of angle B is 90 minus 53.1, which is 36.9 degrees. Okay, last example. These are word problems. If a guy wire for a tree is 14 feet long, making a 41-degree angle with the ground, how far is the base of the tree from the stake anchoring the wire? So here's my stake. Hang stake here. Here's my 41 degrees. The guy wire is 14 feet here. And it's asking me to find this distance. So from the guy wire to the tree. So 41, this is my reference angle. So if this is my reference angle, this is my adjacent leg, and this is my hypotenuse. So I know these two sides tell me I am using cosine. So the cosine of 41 degrees equals x divided by 14. So I'm going to solve for x. X equals 14 times the cosine of 41 degrees. And I put the 14 in front of the trig word, so not afterwards. That is standard placement. So x is approximately 10.6 feet. Okay, that's it.